Okay, I'm flying solo today, so it's just going to be me on the video. But we're entering chapter 4, and we're starting the primary study of graphs and their pictures and what happens. So we're going to start with the baby stuff. Notice our title today says Relations and Functions. So that's what we're going to tell you what the difference is between those two. All right, so the first one right here. A relation is a set of ordered pairs. You can pair anything that you want. So for example, most traditionally, you guys will think of numbers. So I can do 1 paired with 3. I can do 5 paired with 4. And I can do 6 paired with 8. And we call this whole thing a relation because we just paired them all together. But I can pair anything together. I can pair an apple with a dog. I can pair the sun with the number pi. It's just putting two things together. So this is the lowest form. Then we go one step higher, and mathematicians like a function, because once they get their ordered pairs, they want them to have specific properties. And the first property you're going to learn about today is a function. And a function is a relation in which no two ordered pairs have the same first element. So if I looked up over here and I looked at my first relation, would that be a function? No two ordered pairs have the first element the same. So the first element here is a 1, a 5, and a 6. So this is a relation, and it's also a function. Look at this one. Apple, sun. They're not the same. So this is also a relation, and it's also a function. Now we don't call them both. It's whatever describes them better. So really these are functions because that's a better name for them. All right, so you're really going to have some simple homework. You're going to tell yes or no, or sorry, whether everything is a relation or a function. So I look at this first one right here. Let's call this number 1. Is this a relation or a function? Well, what it's saying right here is 1 pairs up with D. 2 also pairs up with D. 3 pairs up with E. 4 pairs up with F. And 5 pairs up with F. All right, so by order of definition, is this a relation or a function? Well, all I have to do is look at my, let's do stars. Look at my first element. 1, 2, 3, 4, 5. They don't repeat. So this is a function. Okay, let's look down below here. This is also called a mapping. And we're going to figure out, is this mapping a function? Well, 1 pairs with A. 1 pairs with B. And, well, I could keep going, but I pretty much already have my answer. 2 pairs with B. 3 pairs with A. And 3 pairs with C. So right here I can see along that the first element repeats here, and then I have another repeating here. So this is not a function. This is just a relation. It doesn't have the chutzpah to be a function. All right, let's look at this down here. This is easy. It's already paired out. So let's just check out the x value. 2, 4, 11, negative 21. We're not worried about the y values. No x values repeat. So this is a function. All right, and the last one over here we're going to look at, a little different. Let's call this example 4. Let's see, there's a lot of pairings going on here, but I can immediately see right here that if I look right here, that is the point over 1 up 0. And this is the point over 1 up 1. And this is the point over 1 up 2. And why do I have to look any further? Right here, my rules of a function are violated. A function cannot have x values repeat. And I'm getting a lot of x values repeating right here. Right here, right here, these repeat. These are all paired off. You know, girls, you understand this function. It's called the two-timing relationship. Oops, let's delete that. I pulled out the wrong thing. Sorry. Come on. It's a relation. This 1 is going out with 0, and then it's going out with 1, and then it's going out with 2. So it is only a relation. It is not a function. Okay, we have something called the vertical line test. And a vertical line is that. And a vertical line test we use to test graphs, to see if they are functions. Because graphs are a picture. So it's a little harder with a picture, so we came up with this vertical line test. So let's see what it does. Okay, here's my red line right here, just in case you can't see it. Right there. Is this a function? Well, I'm going to grab a vertical line, and let's take this one right here, and let's make that line, whoops, get that out of here. Let's make that line green. Boy, everything's popping up. Now I'll get it. There we go. Let's make that. Come on. Green. So the vertical line, if we pass this vertical line over the red line, is there any place that this green line will cross that red line more than once? Nope. So this is a function. In fact, it's called the constant function. And it's in the form y equals a constant. In this case, it's the constant y equals 3. No matter what value you put in for x, the answer is 3. If I put a 1 in, the answer is 3. If I put a 2 in, the answer is 3. If I put a 3 in, the answer is 3. So yes, this is a function. How about this? Is this a function? Well, let's grab our little green line. And let's pass it. And is there any place where the green line is going to cross the red line more than once? Nope. So this is a function. And in fact, this is called a linear function. You learned this back in Algebra 1. Y equals mx plus b. Is this a function? Here's our green line again. And Yes, it is. It passed the straight line test. No matter where I put it, it only hit the graph once. Anybody know what kind of function this is? Right, this is your friend, the quadratic function. The form y equals ax squared plus bx plus c. All your factoring fun. So you may be asking, is there anything that's not a function? Oh yeah, we're getting there. Some of you kind of already caught on to it. Is this a function? Here's my lovely green line. Anywhere I drop the green line, no matter where I put it, it only crosses once. So yes, this is a function. And those of you might be saying, oh, yep, we get it. It's the absolute value function. Ah, finally, something different. Is this a function? Well, I take my green line and it passes in more than one spot. It hits it twice, right here, and right here, and almost everywhere else. So is this a function? No. This is a circle. And you probably learned in algebra the formula for a circle is x squared plus y squared equals r squared when it's at the center, and x minus h squared plus y minus k squared when it's not at the center, at the origin. We're going to do circles more, but right now all you had to come up with is, no, this is not a function. Oops, same question. How about this one? Is this a function? Well, when I take my green line and put it over there, what do you think? That's right. You got it. Very good, Molly. This is not a function. It hits the line an infinite amount of times. So if I were to take this graph right here and I were to take the points off of it, and I were to do it the old-fashioned way like we did in the beginning of the video, this is the point 4, 0. This is the point 4, 1. This is the point 4, 2. This is the point 4, 3. And as you can see, my x values are repeating. So therefore, it is not a function. All right, is this a function? Yep. No matter where I put my green line, it only crosses once. And in fact, this is called a sine wave function. We're going to do that later on, around February. How about this? Is this a function? No, let's see. Passes once, passes once, passes once. Hey, what's going on right here? Now, if we zoomed in on this, this is actually an asymptote. So these curves get really, 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 really close to the y-axis but never touch it. And no, that red line and that green line never meet, because if I put that green line right on the y-axis, but the y-axis is being an asymptote and this never crosses, it looks like it's going to become a vertical line, but it doesn't. So if this is a function, yes,